Hello students, in the previous class we have seen the chemical kinetics. Today let us discuss about photochemistry. So what is photochemistry? In the name itself, some chemical reactions is taking place in the presence of light. Okay, this one we call it as photochemistry. For example, if you on the tube light, so what happens immediately within a seconds? It is exhibiting light. So means what? There will be some change in that. Some chemical reaction is going to take place in that. So it is showing some visible. So means what? Whenever the chemical reactions which is undergoing in the presence of light, that when we call it of what? Photochemistry. So by this what we can say here? The photochemistry is nothing but here. This is a branch of science. This is a branch of science which deals with chemical reactions in the presence of light. In the presence of absorption of radiation also we can say. So this is nothing but photochemistry. So here it mainly depends upon this radiations mainly depends upon what? Wavelength. So the wavelength which will lie in between. Okay, the wavelength which will lie in between visible and UV light. The wavelength lie in between visible, that is 8000 angstroms to 2000 angstroms. It is having the range. So within this only the wavelength is going to express. So coming to here, what happens? In this region only the light is going to exhibit. Such reactions we call it as what? Photochemical reactions. Okay. So means what we can say here? Whenever the absorption of radiation and the quantum of energy is observed, that when we call it as photon. Okay, so means what? The frequency of radiation is also there, which will depends upon the frequency of radiation. For example, photon we am saying, which will be primary unit of the radiation. So mainly the photochemical reaction depends upon the absorption of photons, we can say. So what is photon here? So photon is nothing but the radiation or quantum of energy is observed. What is photon here? Quantum of energy is observed. We call it as what here? Photon. So it mainly depends upon frequency of the radiation also. So which can be both, and means what here? These type of reactions will include oxidation, reduction, decomposition, combination, hydrolysis, polymerization. When you take ordinary reaction, that all will undergo thermal reactions. Okay, so there will be decrease in free energy, but coming to here it will increase in free energy. Photochemical reactions will increase free energy, thermochemical reactions will decrease free energy. For example, if you take carbohydrates from carbon dioxide and water, so generally it will what here? Increase energy. So when you prepare CO2, 6CO2, 6H2O in the presence of light, what it is going to give here? C6H12O6. Okay, C6H12O6 it is going to give. In the presence of carbon dioxide and water, what will be happening? It is losing oxygen molecule. If you have been seen C6H12O6 and it is losing oxygen molecule in the presence of light, here chlorophyll is active. So means what here? Energy is increasing. Okay, so these type of reactions we call it as what here? Photochemical reactions In the same way, if you take thermal reactions, when you take thermal reactions, what happens? It acquires some activation energy by collision. The molecules will collide and it acquires some activation energy. So mainly it depends upon the photochemical reaction, outside source of energy reaction we can say. That's why we are saying that absorption of radiation is always quantized, means the quantum of energy is observed. We call it as a photon. So this photon will depends upon the frequency of radiation. So that's why we write it as E equals to h mu, where h is equals to Planck's constant, E is energy, mu is nothing but frequency. Okay, so this frequency is nothing but what here? Velocity of light per wavelength. So then if you substitute here, E is equal to hc by lambda, where E is equals to hc mu bar. So mu bar is nothing but wave number. Okay, so this is the wave number. So this will be equals to 1 by lambda, that only we have written here. So by this what we can say, the energy which is observing is directly proportional to wave number. Okay, so this is about general introduction. So by this what we can say, whenever the absorption of light may raise a molecule to an excited electronic state, it will involve the promotion of electron from molecular orbital to an antibonding molecular orbital. So then what we can say, atom molecule which will undergo chemical reaction in the ground state only, that when we call it a Jablonski diagram. So generally absorption of light take place in two types of reactions. Absorption of radiation is of two laws, that is, first one is what here? Absorption of radiation is of two laws. What we can say here? That is of photophysical process, Lambert's law, and Lambert's law, which we have already discussed in the spectroscopy. Lambert's law is nothing but what here? When a monochromatic light passes through a homogeneous medium, it is directly proportional to intensity of light observed. Okay, and coming to here, Beer-Lambert's law is nothing but what? Same thing, when a monochromatic light. So means what? When a monochromatic light is passed through a homogeneous medium, it is directly proportional to intensity of light and concentration of the solution. That one we call it as Beer-Lambert's law. So generally photochemistry consists of two types. It is of two process. What is first one? Photophysical process. Second one is photochemical process. In photophysical process, so photophysical process is nothing but what here? It will absorb light without undergoing any chemical change. So what is photophysical? Physical means what? In the presence of light, without undergoing any chemical change, we call it as a photophysical process. Okay, so what happens here? It depends upon the nature of the absorbed light, we can say, and here with which it will give light. This one is of three types generally we are having. So if it is having sufficient energy, it is having actually three types, that is, if the absorbed light is sufficiently energetic, So then what happens? The electron jumps from higher orbit to the lower orbit. Okay. So means what here, if you take ground state, so it is generally jump to excited at ground state. So this is the transition. So here what happens? This is excited state. So when the light is observed here, so it is having some energy. Then electrons move from ground state to the molecules will move from ground state to excited state, or may they leave the atoms completely also. So this is the first process. And coming to second process, if the absorption of light is emitted immediately, that one we call it as fluorescence, means it is coming back, that one we call in the presence of light. So this one we call it as what? Fluorescence. So what we can say here, if the absorption of light is emitted instantaneously, we call what? Fluorescence. Okay, so if suppose phosphorescence is no nothing but what? The absorption of light is emitted after some time, that one we call it as phosphorescence. Okay, this is happening immediately, that one we call it as fluorescence. If the absorption of light is emitted after some time, we call it as phosphorescence. Okay, so this is nothing but photophysical process. Coming to photochemical process. Photochemical means what? In the presence of light, a chemical reaction take place. That one we call it as what? Photochemical process. In the presence of light, a chemical reaction occurs. We call it as what? Photochemical process. So here if you take here H2 plus Cl2, in the presence of light, what will be getting? 2HCl. So this is about chemical reaction. Okay, and also here if you take 6CO2 plus 6H2O, so what you are getting here? In the presence of light and the chlorophyll, so you are going to get C6H12O6 plus 6O2. Okay, so this is the reaction in the presence of light, it is going to take place. So these are the two processes of a photochemical process. So coming to here, next we are having the difference between photochemical and thermochemical. So let us see here photochemical reactions. Thermochemical reactions. Okay, so what is photochemical reactions? So photochemical, as we know, the reaction which is undergoing in the presence of light, that one we call it as photochemical. The reaction which is undergoing in the presence of heat, that one we call it as thermochemical reactions. So what is photochemical reactions? We can say the reactions involve the absorption of photons of light. The reactions involve the absorption of photons of light. We call it as what? Photochemical reaction. So coming to thermochemical, the reactions involve the evolution or absorption of light. We call it as what? Thermochemical. So means what here? In the presence of light only it will take place, the reaction. And coming to here, in the presence of heat, we can say here not in the presence of light, we can say. The reaction is going to take place. Okay, so coming to here, generally the rate of reaction, it will not depend upon rate of reaction. Coming to here, it will also not depend upon rate of reaction, but it depends upon the intensity of light. Okay, so it depends upon the what here the temperature what will be having, it will not depend upon, it will not depend upon the rate of reaction, but depends upon the intensity of light, we can say. But coming to here, it will not depend upon rate of reaction. Okay, and one more thing, so what is the difference? The free energy change if you have been taken, so it is not negative, it is positive. So what we can say here, the delta G is positive here, the free energy change gives free energy. Here the delta G will be negative, we can say. For example, if you have been taken reaction HCl, so what happens, it will give positive reaction. Coming to here, the activation energy will be applied through the absorption of light, but coming to here, the activation energy is required in the presence of collisions in the form of heat. So what we can say, the activation energy, the activation energy is gained through presence of light, the activation energy is gained through presence of heat, we can say. Presence of heat. Okay, so this is about the differences between photochemical and thermochemical reactions. And one more thing we can say here, only here specified molecules only promoted to excited state in photochemistry, but coming to here in thermochemical reactions, no need to observe, there will be no selective species, they can take place any molecule, all the molecules in the presence of light also. So this is about what here, this is about general introduction of the photochemistry. In the next class we can speak about the laws of photochemistry. Thank you.